Okay, welcome to part 2 of correlation, and in this lecture we're going to be talking about Spearman's correlation. All right, so what is Spearman's correlation? It is used to determine the strength and direction of the monotonic association or relationship between two continuous or ordinal variables. Okay, so how is this different than Pearson's correlation? Well, we've relaxed the linearity assumption. So we are no longer requiring a linear relationship. Now we are saying, okay, it can be relaxed to monotonic. And what do I mean by monotonic? Monotonic just means that the function is only increasing or only decreasing, but it's not increasing and then flattening out and then increasing, or increasing and then decreasing and then increasing again. It is only increasing or only decreasing, and we refer to that as monotonic. And we're also now saying, okay, well, we can have two continuous variables or ordinal variables. So ordinal variables are discrete and ordered, like on a Likert scale. So something that may be on a 1 to 5 scale of strongly disagree to strongly agree would be referred to as ordinal. An example here would be looking at math achievement and educational aspirations. So educational aspirations tend to be from as low as do not plan to graduate high school all the way through completing a PhD. And so those are discrete and ordinal. And then math achievement, of course, is a continuous variable. The value, much like Pearson, ranges from -1, which here means a perfect negative association of ranks, to +1, which is a perfect positive association of ranks. So statistically, the way Spearman's correlation works, and I'm not going to go into a lot of detail here, is that it ranks the data and uses the ranks. All right, and a value of 0 indicates no relationship between the two variables, and it's denoted as R sub S, or sometimes the Greek rho. All right, assumptions. Both variables are measured on a continuous or ordinal scale. Much like before, the variables are paired, so each case or individual has a value for each variable. And then our last assumption is that monotonic relationship existing between the two variables. All right, and again, we can use a scatter plot to visually assess the monotonicity. But the good news is we're no longer worried about linearity, outliers, and normality. All right, so just to give you an idea visually of what a monotonic relationship looks like, in the scatter plot on the left, we see a scatter plot of monotonic decreasing relationship, and it looks a little bit linear to us. But then notice in the scatter plot in the middle, we see a monotonic increasing relationship, but this looks to be a little bit more exponential, right? So it's not going to have that linear assumption to it. And so we would want to use Spearman rho here. And then on the right, we've got the non-monotonic scatter plot, and so we see that parabolic relationship, and so there the monotonicity would be violated, and we would not be able to use Spearman rho on that last scatter plot. All right, so we wish to explore the correlation between rural identity and rural aspirations in high school students. Both variables represent averages of items on a 6-point Likert scale from 1 equals strongly disagree to 6 equals strongly agree. Let's check our assumptions first. Okay, so I'm going to go over to JASP. Uh-oh. Okay, so we want to run a correlation between rural identity and rural aspirations. So let's go into regression and correlation, and we're going to add rural identity and rural aspirations. And these are just math high school students. And if we are thinking we're going to try a Pearson's R here, we would definitely want to select flag significant correlations. We'd want to go down to assumptions and check our Shapiro-Wilk. And we can also take a look at a scatter plot. Okay, so we're thinking, we're bebopping along. We're going to interpret a Pearson's R here because both of these variables are continuous. We can look at the scatter plot. We don't see any obvious outliers, and we see that we could probably make a linearity assumption here. However, if we look at the Shapiro-Wilk test for multivariate normality, we see that the p-value is less than 0.05. This is telling us that there's a violation of normality and that we really cannot use Pearson's R in this situation. And so what we need to do is we need to come back over to the correlation and uncheck Pearson and check Spearman Rowe. All right. And so now we do see a monotonic relationship, right? And we no longer need that normality assumption. All right, so at this point, I can go back to our slideshow. All right, so going back to our results, we do see that the Shapiro-Wilk is 0.044, so we've got a problem there, and the null hypothesis is rejected, and there's evidence that the data tested are not normally distributed. All right, so when it comes time to interpret the correlation, we see a significant correlation of 0.391. Is that also an effect size? And yes, we can interpret the Spearman's value as an effect size, that very similarly to how we did Pearson's correlation, where less than 0.1 is trivial, 0.1 to 0.3 is a small effect, 0.3 to 0.5 is a moderate effect, and greater than 0.5 is a large effect. All right, and so here we would say there is a moderate positive association between rural identity and rural aspirations in high school students, and we would report that Spearman R as well as the p-value. All right, so what about reporting all of the results? How does this change from Pearson's correlation? We would start by saying a Spearman rank order correlation was run to assess the relationship between rural identity and rural aspirations in 1,176 high school students. Preliminary analyses showed the relationship to be monotonic as assessed by visual inspection of a scatter plot. You could also here give the Shapiro-Wilk results showing that there was a violation of normality. And then we would say there was a statistically significant, moderate, positive correlation between rural identity and rural aspirations, reporting that Spearman R and the p-value. Again, how does this change if the p-value was greater than 0.05? Then we would just simply say there was no statistically significant correlation between rural identity and rural aspirations, and we would report that small R for Spearman as well as the non-significant p-value.